In the previous video, we looked at the homogeneous higher-order ODEs. In this video, we'll look at the non-homogeneous higher-order ODEs. We'll start with an example. In this example, we have y triple prime plus 3y double prime plus 3y prime plus y equals to 30 e to the power of minus x. In the written notes, I've got to write down the plus y. Sorry about it. We also have the initial conditions y naught is equal to 3, y prime naught is equal to minus 3, y double prime naught is equal to minus 47. We know that for any non-homogeneous ODEs, the solution contains two parts. The first part is the homogeneous part. The second part is the particular part. For the homogeneous part, we'll write down the characteristic equation. The characteristic equation is simply lambda cubed plus 3 lambda squared plus 3 lambda plus 1 equals to 0. You can see the left-hand side of this equation is also lambda plus 1 cubed. So lambda simply equals to minus 1. Then you can write down the homogeneous part of the solution, which is c1 e to the power of minus x plus c2x e to the power of minus x plus c3x squared e to the power of minus x. For the particular part of the solution, we don't have a good way. We can only take guesses. The right-hand side of this equation is 30 e to the power of minus x. So it is natural to guess yp is equal to e to the power of minus x. I apologize for another typo here. It's supposed to be e to the power of minus x instead of e to the power of x. By substituting yp into the original equation, this is what you get. As you can see, the left-hand side of this equation is equal to 0, and the right-hand side of this equation is 30, so there's no solution. Next, let's try yp equals to cx e to the power of minus x. Again, there's no solution. And next, let's try yp is equal to cx squared e to the power of minus x. Again, there's no solution. Keep trying. Next, let's try yp equals to cx cubed e to the power of minus x. By doing simple differentiation using the chain rule, you can easily write down what is yp prime and yp double prime and yp triple prime. Substitute what we have here into the original equation, which is y triple prime plus 3y double prime plus 3y prime plus 3y. I'm sorry for the third mistake in the written notes. It's not 3, it's supposed to be 3y, equals to 30 e to the power of minus x. This step is just simple substitution. This gives us c equals to 5. Thus, yp is equal to 5x cubed e to the power of minus x. Then the general solution is the homogeneous part of the solution plus the particular part of the solution. And finally, we need to satisfy the initial conditions, and we'll get c1 equals to 3, c2 equals to 0, c3 equals to minus 25. And this is the final solution, which I'm not going to read out. Now, let's do a really quick recap of what we have covered so far. We have looked at the first-order ordinary differential equations, second-order ordinary differential equations, and the higher-order ordinary differential equations. From the next video, we'll introduce a new method called Laplace transform and how to use Laplace transform to solve differential equation problems.